Hi, welcome back to another episode of Algebra in Words, the video series on YouTube. In this episode, we're continuing our discussion on multiplying polynomials, and we're focusing on special cases. In the last episode, we looked at the special case of multiplying two conjugate binomials. In this episode, we're going to be focusing on the special case of a binomial squared. Now, in this episode, I'm going to give as much overview of the details as possible, but it's not going to be that long because we're really only going to look at a couple problems. But I will be sure to explain them thoroughly so we get a good overview of all the important details. Now, to start, why is this called a binomial squared? Well, basically, what could normally start as x plus 2 times x plus 2, obviously those groups are the same, so we can just consolidate them and call them the group squared. Now, this is a special case because of the way, it's not really a shortcut, but it's sort of a special method that we use to multiply a binomial squared. So let's look at that first, and then after that I'll make a quick comment about what happens if you expanded this into two binomials and FOILed it, which is fine, but I'll get to that in a minute. But first, let's give the procedure that you're going to use for multiplying a binomial squared. Alright, so I'm going to explain it first and then we'll do it. The procedure is like this. First you're going to square the first term, and then what I like to do is leave a little space, then square the last term and write that here, and then in the middle of the two terms, what you're going to do is multiply the first term times the last term, multiply that times 2, always by 2, and that will make the middle term. We'll verify that by FOILing it, okay, but there's a special reason why we want to follow this method, and that's basically for when we get to doing the reverse, which is factoring. I'll explain that in a little bit, but now let's do the procedure. So we're going to square the first term, that would be x squared. Now we're going to leave a little space, we'll do that last, and then we're going to square the last term, which is going to be plus 4. And now for the middle term, this is the key part. The first term times the last term doubled, meaning always multiplied by 2. So 2 times x is 2x, doubled makes it 4x. So the binomial squared, x plus 2, makes x squared plus 4x plus 4. Now let's just pause here and let me explain what this is. A binomial squared always results in what's known as a perfect square trinomial. Now that's very important to know, especially when we get to identifying and factoring perfect square trinomials. Let me briefly explain what makes this a perfect square trinomial, because the details of each term are what make it a perfect square trinomial. That's when the first term is a perfect square. Okay, x squared is the result of x squared. That's pretty obvious. I'll do the middle term last, but then the last term is also always a squared resulting from the square of something. In this case it was 2 squared. But the middle term is always the result of the product of the square root of the first term of the trinomial. So let's call that the square root of x squared, times the square root of the last term, and if we call that square root of 4, that would obviously reduce to 2. And as I said, always times 2. So in summary, so if we were to reduce this further, the square root of x squared is x, the square root of 4 is 2, and we always multiply those two by 2. And if you notice, x times 2 times 2 gives us 4x. That's the middle term. And that's what makes a perfect square trinomial. And to summarize that, when the square root of the first term of a trinomial and the square root of the last term of a trinomial times 2 equals b, the middle term, in this case 4x, then that means that this is a perfect square trinomial. That's a subcategory of trinomials. Alright, and also why that's important is because when we go from perfect square trinomials and factoring that, we always want to factor them into a binomial squared. That key element is going to come into play when we do the complete the square method, which is also going to play a little role into when we do circles a little bit later. So that does have meaning and purpose that will come back to for us to use later. But in the meantime, let me erase this and let's do one more problem, and then we'll also FOIL it. Okay, and before we do the last problem, I said we're going to FOIL it to compare it. So let's FOIL it. Just to sort of check if the shortcut method that we used works. So let's just expand this as x plus 2 times x plus 2. And so let's just FOIL it. Product of the first, x squared. Product of the outside is 2x. Product of the inside is 2x. And product of the last, 2 times 2, is 4. Notice that the two middle terms are like terms, they're 2x. And that makes 4x, which is the same as the b that we got above. But let's pause there and just look at this for another second and focus on what's happening. Yes, these are like terms, but more importantly, notice they're the same terms. That's why when we multiply this first term times the last term times 2, that's where the times 2 comes from. Because if we were to do it the long way, the FOIL method way, the product of the outside and the product of the inside will always be the same. And another way of showing adding two things that are the same is multiplying by 2. So that's where the times 2 comes from when doing the shortcut method for multiplying a binomial square. So I hope that makes sense. And let's do the last one, and again we're going to apply the special case method for a binomial squared. Square the first term, so that's squaring the 3 and the x to make 9x squared. Leave a little space, square the last term. Negative 4 squared is going to be positive 16. And now, what will be the middle term? Try to think of it before I write it. Well, it's going to be the first term times the last term times 2. First term times last term, 3x times negative 4 is going to be negative 12 times 2 makes negative 24. And don't forget the x. Now, so once again, we translated or multiplied a binomial squared and got a perfect square trinomial. Now, let's just make sure that this is a perfect square trinomial by definition. Well, the first term is a perfect square, the last term is a perfect square, but what about the middle term? Is the middle term the product of the square root of the first term times the square root of the last term times 2? Well, the square root of the first term, 9x squared, would be 3x. Notice that's what we had here. The square root of 16 is 4. So when we do 3x times 4 is 12x times 2 is negative 24. And if you're wondering where the minus comes from, that's because this was minus, so this will be minus. And also, if we really wanted to be specific, we should have and could have put the negative in with this 4 because it came from here. Alright, so in short, this is a perfect square trinomial, and that makes sense because a binomial squared will always result in a perfect square trinomial. Again, this will matter when we factor in the reverse, taking the perfect square trinomial and factoring it back into a binomial squared. And it may sound easy and it may look easy now, and it is easy. However, what becomes the challenge is when you have a bunch of different forms of trinomials and quadratic expressions or equations mixed together. What becomes the challenge is identifying what type they are, and once you identify what type they are, that's how you know how to factor them and what to factor them back into. So this all takes a little practice, but especially attention to the details and a focus on the details and the little nuances there. So anyway, that's all we're going to do in this video. When you're doing your homework, again, remember to apply the method of product of the first times product of the last times 2 to get the middle term, and that should get you through it. So anyway, I hope you found this little video helpful. If you did, please give a thumbs up. Please share with your friends. Please subscribe to the channel, and also hit the little bell so that you can be alerted when new videos come out. Also, be sure to check out the content on other platforms, Facebook and Instagram, and I'll see you in the next video where we're going to be looking at doing a binomial cubed.